April the 15th, 2025. Guys, you're looking at images of our sun. This goes back a few days. Notice your timestamp at the bottom. There's the 14th. We're coming up into the 15th. We've had what's called a full halo coronal mass ejection. It's actually from 2 filament releases. And you see this comet coming in right there. It's larger than some that you see. There's no tail on it. And then you see the explosion come out from behind this. You're looking at LASCO C3. It gives you a very, very wide view of our sun. This satellite is between the Earth and the sun. It's about 1 million miles from the Earth. Again, here comes that comet right there. And again, it's called an Earth-facing perspective. It tells us what's coming at the Earth from our sun. Now, this blue disk, called the occulter disk, is there so it blocks the glare. It's like holding your hand up to the sun so you can see something else. And this fuzzy section right here is basically just the arm that holds that disk there. The sun is only the size of the white circle. And then, again, as we watch this comet come in here in just a moment, you see it slide through there. You always see a reactive explosion on all of these comet impacts. Sometimes as it hits the sun, here it comes, that will actually blast or throw a blast out the opposite side. I've seen that happen. But here it comes in, we get a double halo burst facing the planet from, again, 2 filament releases. Now, when I see these comets come in like this, it always makes me think of how the angel in Revelation will pour that vial or that bowl out upon the sun and then causing the heat to scorch men. And you know the rest of that story. But this is what we have now. It's not that powerful of an explosion on a list if you look at the largest. But it is going to create a geomagnetic storm. It is going to have impacts on our planet. And it is going to affect people like me and a lot of you that can feel these pressure effects. Not only that, with the pressure building, guys, it definitely is increasing straight line wind speeds. Here it's a beautiful day, but it's kind of windy. I like it. It feels good, but the winds are just a little strong. So when you start getting involved in these storms, that's going to be a major factor. Now, I want to enlarge this just to this bottom left quadrant of this image and give you a better look at this comet as it comes in through here again. Timestamp, we're going through the 14th. Here we go. Right there. And as it gets closer, it actually goes behind this arm that's supporting this disk. And unlike the SDO satellite, guys, it shows you the sun. But this one wants to give you a perspective of what's outside and what's coming and what's going out as far as coronal mass ejections and things like that. Now, this camera is called LASCO C2. Same satellite, different camera, and this one gives us a much closer look at the sun. It's not that 1 million mile wide pan in every direction. Check this out. You'll see that comet come in here right through there, but look at the power being put out from our sun. In the Earth, it would take, I think I counted 119 if you put them to specs as far as comparing size to size or to scale. There's the comet. It would take 119 of our Earths just if you pasted them across here to go along with that scale. So it's an immense object there that's keeping life in this universe going. Now, switching satellites, guys, this is called the Solar Dynamics Observatory. It is another Earth-facing perspective satellite. And what we're having is we've got sunspots here, but these filaments, they're thousands of miles long, and they're floating on the surface, guys. When one end of one of these long filaments touches a spot that's kind of active with the energy from the sun, you see radiating everywhere, they will launch one end in a whip-like motion straight out. Now, what we're dealing with when we watch these things flare up, there's 2 flares involved in a filament release. The initial light burst that hits the Earth in 8.2 minutes. Then you have the collapse of the filament as the gravity overtakes part of it that's not released into space, collapses it back onto the surface and creates these giant canyons called Hyder flares. They again shoot out an emission of X-rays at light speed. Now the energy, you see the protons that are floating off there in these waves, like right there. Now that's going to take a couple of days to get. If it was coming straight at Earth, it would take a couple of days, but at the speed of light, 8.2 minutes for any type of optical burst from the sun to reach our planet. Not very long at all. When you are looking at 93 million miles, it separates us. But this is the energy that's involved with what you were seeing on the satellite before, these filament releases. This is what they're saying on the CME tracking. All of these links are on our website, guys, at bpearthwatch.com. If you're looking in the green line right there, this represents Earth. This red line is a stereo satellite that's just in front of Earth right there. It's in the same orbit, and it's called stereo head. It gives you a look at what is, it gives you a side look at the sun, depending on where it's at in the orbit. I remember years ago, you had the Earth here. Stereo A was here and stereo B was here. We had it triangulated perfectly for backside eruptions or anything, but as the orbits continue, then it changes. And so now this is what we have. But both stereo A and B were well past their life, but we're still getting some images. But right here, you're seeing an impact. And like, again, the Earth is in the green lines. This is the thickness or the plasma density. And it's in centimeters cubed. And right here you have a pretty good wall of impact coming in. Now, it doesn't have high numbers. I've seen it stronger than that. And then down here in this chart, radial velocity means solar wind speed. That's how fast it's coming at us. And we're dealing with probably around 550 to 600 kilometers per second when it hits the Earth right there. See that? And that's on the 16th. It's going to be very close to, and again, this is UTC time, so you're looking tonight at midnight. We're going to narrow that timing down just a little bit, but we do have incoming. You can see right there. That's those two filament releases. The Earth is right there. Again, I've seen them much stronger, but main reason I'm doing this is because the effects on the health of people, your heart arrhythmias, and all of that are dizziness, fatigue, headaches can be caused by this pressure, and the pressure is increasing. Thus, you're seeing increased straight line wind pressure and volcanic and earthquake activity pick up. Again, we'll take a look at this timing on the impact. You'll start feeling it. We'll start getting impacts on our Discover satellite, sometimes 45 minutes. Depending on the speed of the solar wind, of course. Before it hits Earth, we get a little bit of heads up from that. But again, looking at it right here, this would be if you were in UTC time, real close to midnight tonight. But you take about 5 hours back from that, guys. So you're looking at possibly 7 p.m. tonight, East Coast time, for the impact of this. Again, I don't think it's going to be like a jolt, major quakes. I hope I'm wrong about that. I mean, I hope I'm right about that. But what I'm, again, concerned is every time I do one of these videos, more and more people come in and say the effects are really devastating to them. They didn't know why. Now, another link on our website is spaceweather.com. Scroll down to the left, you'll find all of the links we're talking about. We're in a geomagnetic storm watch, a G2. It says the geomagnetic storms are likely on April 16th when a pair of closely spaced CMEs is expected to hit Earth's magnetic field. NOAA forecasters say storm levels could reach category G2 with auroras across Canada and the northern tier of the U.S. states. The CMEs were hurled towards Earth by a double eruption of the sun. That's what we were looking at just a few minutes ago. Now, in the top left, you'll see the solar wind speed is 380.2 kilometers per second. 320 is about average, but like I said, we're going to be getting up around 6 kilometers per second, or 600 kilometers per second, and you're over 1 million miles per hour when that happens. That is unfathomable to the human mind, and it creates a lot of pressure. Now, what's unique about the sun has a magnetic field also. The Earth has one. But they're weak compared to what some of the engines that have been created, like CERN and some bigger motors and generators. The Earth's magnetic field is 100,000 times weaker than CERN's. We've seen it many times when we CERN would crank up. You could see the models of the magnetosphere, our shields, pull in towards the planet and collapse in very low. A lot of problems occurred during that period of time. But CERN has got a new technology now, and they're incorporating it into the runs for 2025 this year, and it could possibly boost the energy by maybe 10 times of what they've been dealing with. We've seen luminosity reach at 13 teraelectron volts, or 13.5, and we may be talking about a lot more power than that. How will that affect the Earth's magnetic field? That's so critical. But let's take a look at that just a moment. Now, this is the data input coming from the Discover satellite we just clicked on. You got, let's see, 5 things you can look at here. At the bottom is the temperature of the solar wind speed as it's coming towards our planet. Right through here, you can see the rise. Then this is a solar wind speed. Again, we're down. They were saying around 360 here. That's 400. And it's a little above average. But when this thing starts jumping up into here, you got a lot more speed, a lot more pressure. This is the density. And this is live right now, guys. This is what's headed towards our planet in the density factor. It's not quite here yet. But up here at the top, this has everything to do with the cracks and the openings in our magnetic shield. The black line, which they call the BT, is how much power is involved in the shields itself. The energy from the sun striking our shields, what is it measuring? That's what this is right there. Now, I talked about this in a video the other day. The red line, called the BZ, is important to watch because you have a 0 line right there, and that's kind of a neutral balance of positive and negative. The charge on our shields compared to the charge on the sun's fields. So when you, again, have like charges, 2 magnets, positive pointed towards each other, they repel. So when this is in the positive, like you see in here, the shields are very strong. They're much stronger because it's matching the polarity of the sun, and that increases the repelling energy. But when they dip down low, then that polarity changes. Now we're starting to get into the positive, negative aspects of it, and it opens cracks in our magnetopoles, in our shields right through here. We saw that the other day with the quake in California. I've seen it many other times, but this one, of all the things on the charts, when this thing really dips down low, that's when we become more exposed to this radiation. You can see it in this chart here in the pH called the GSM PHI. And where you see these dips in the pink, that's when the shields have cracked and we're getting the openings. You can see it here also in the very thin purple lines. But this magnetism has everything to do with why the video I did the other day about the Earth's magnetism and the pole reversals. The sun does it every 11.8 years or so, but it could be millions of years before these magnetic parameters change on our planet. Going right now, everything goes out the North Pole. That's why your compass points in that direction. But guys, when the magnetic poles flip, what will happen? How long will that take? We don't know because none of us have been alive during one of these events. You looked at that chart the other day. It goes back 5.25 million years on data collected from the magnetic reversals here on our planet. But when the critical moment would be if the Earth magnetic field gets so out of whack, we start seeing large openings in this, what's called the BZ line here on our polarity of our magnetics, then we're going to be in trouble. The more you see this down below there, the more, or the redder the auroras will be, the higher the pressure on the Earth will be, the stronger the wind will be here, and the more radiation that will pour in. Now, going back to the lead page on spaceweather.com, they're talking about space weather balloon data, and that's what the balloon is showing here. But they're saying that the students get together and with the Earth to Sky Calculus group, and they fly these balloons up into the stratosphere over California. The balloons are equipped with sensors that detect secondary cosmic rays, a form of radiation from space that can penetrate all the way down to the Earth's surface. And guys, when you see that red line dip, on that chart we just looked at, you're creating cracks for this to increase. And this is again, secondary cosmic rays, a form of radiation from space that can penetrate to the Earth's surface. Who lives on the surface? We do. Our monitoring program has been underway without interruption for 10 years, resulting in a unique data set in the atmospheric measurements. What you've got here, guys, is solar cycle 24, then here, solar cycle 25. This is the radiation going into the peak of solar cycle 24. It increased. See that? But now, as we're getting into coming out of the peak of 25, we're starting to see the radiation decrease. And this is where they're launching this from right here. It's very close to Vegas area across the border there. But it says atmospheric radiation is decreasing in 2024. Our latest measurements in November registered a 10-year low. Again, we're talking about going back now, about 4 or 5 months. What's going on? It says, ironically, the radiation drop is caused by increasing solar activity. Solar cycle 25 is roared to life faster than forecasters expected. And when this cycles, like it says, roars to life, you've got more solar particles bombarding the Earth, but it sweeps away the radiation around the shields. So that's why it's decreasing. Energy picks up and pushes it back. It's like high winds with smoke. It's going to blow it away from the fire. It says the sun's strengthening and increasing tangled magnetic field repels cosmic rays from deep space. In addition, solar coronal mass ejections, called CME, sweep aside cosmic rays, causing sharp reductions called the four-bush decrease. In other words, that CME that's going to come in here or this afternoon or this evening early is going to push a lot of these particles away with it. But it's got its own effect. When things are very calm, there's more radiation penetrating the planet. If it's just sitting there, everything's steady, you got that amount. But then it can increase, decrease very quickly, and that's when we see the changes. It says, who cares? Cosmic rays are surprisingly down-to-earth form of space weather. They can alter the chemistry of the atmosphere, trigger lightning, and penetrate commercial airplanes. According to a study from the Harvard T.H. Chan School of Public Health, crews of aircraft have higher rates of cancer than the general population. And think about the astronauts that were stranded for months. And then you had a group, I guess it was, you would call it the Vixen, from The View, went up on one of the spaceships yesterday, just went up, touched the atmosphere, came back down. But they were exposed. Big time. Anyway, it says the researchers have listed cosmic rays, irregular sleep habits, and chemical contaminants as leading risk factors. A number of controversial studies that list 4 here. 1, 2, 3, and 4. I'm going to link it, or just go to spaceweather.com, scroll down to the bottom, and you can click on 1, 2, 3, 4 studies if you're interested. Go even further. These studies go even further, linking cosmic rays with cardiac arrhythmias and sudden cardiac death. How many people have dropped dead, said it was a heart attack, or the doctors did, or autopsy or whatever, never thought about the sun, never mentioned it, or any type of space radiation. While we are on the heart subject, let me give you a slight update. I didn't mean to put this in here, but I think it's important from what I've learned. It could be important to a lot of people. And I mean a lot of people, because you know that as we were going through all the tests and stuff, they found that I had an aortic aneurysm between my heart and my brain. There was 2 smaller ones in my neck. But so the pain is incredible when your heart starts grabbing you. You can't hardly move. It bends you over, things like that, and it keeps on. You end up in the emergency room, which has happened to me in the last month. And so then they do all the tests, every test they can do. I went up there, I think, 3 times during that month of the emergency room visit. And they did the echoes, they did every CAT scan, MRI, stress test, everything you can do on the heart, they did. And then they look at you and say, you have the aneurysm, but the valves look good, or the muscles seem to be okay. We don't know. It looks like your heart's fine. And they got this blank stare. And I'm talking about the heart specialist at the Baptist Heart Health Center in Jackson, Mississippi. So I knew something was wrong. This is just a couple weeks ago. I knew something was wrong. So, and I also knew that I can dig deeper than any doctor I know into research. So the first thing I did, I found a clinic down in Fort Myers, Florida, that handles, write this down, guys. If any of you, and I know I'm not the only one because they've got clinics for it now, but the heart doctors had no clue. And that's the most surprising thing of all. But what was causing this, guys, is called cervical angina. They had no clue. And I could have walked out of there and died right there because the pain was still intense when they said you can go after the last emergency room visit. Cervical angina, guys, is problems in your neck blocking the signals to your heart. Your heart could be fine, but it can kill you just like a heart attack. It can bring your blood pressure up, and just like a heart attack or high blood pressure or low blood pressure, and it's extremely painful. All the symptoms of the heart attack, the exhaustion, fatigue, again, dizziness, are part of cervical angina. And I've said to myself, and Tina and I were talking about it after we were absolutely disgusted with the so-called heart specialist, not even knowing that term existed. I'm talking about just, it's like, I can't believe it. Has it gotten this bad? Then you find specialists around the nation that know about it. So I actually called back up to the Baptist Heart Division there, and I said, do y'all have a doctor there? And I kind of knew the answer, that can treat cervical angina. They said, what's that? So I educated them. Now, they're not going to push that forward with that information from them. That's why I'm doing it here, because they're paid by the insurance companies to check your heart. And if they send you to a neurologist, then they're out of the money loop. That's how evil it's become. And we have another large hospital here, St. Dominic's. It's part of the Lady of whatever it is, Catholic organization. And they were major players in the disaster that led to the COVID. I mean, they're big time in it, guys. And complicit because they were taking money for murder. So the hospitals are really getting crazy. But if you're having heart pains and problems like that, and I know other people that have been to the hospital over this, and they come back saying, well, they couldn't find nothing. You know, they do blood tests and everything else, and check the different chemicals in your blood. Don't walk out of there and let them get away with that. If you have to educate them, pull it up on your phone, stick it in, and say, I'm out of here, guys, because you guys are so stupid and so embedded in your single fault. There's no longer good doctors out there anymore. I have one that is very good. But these specialists now, I'm waiting for one of them to come and say, well, your left kidney has some problems. And then what would be your reply? Well, what about your right kidney? They'd say, oh, we don't do the right kidneys anymore. You have to go upstairs on the elevator and go down that hall, and they look at your right kidneys. That is a joke, but that is what is happening. These heart specialists that's been there 30 years or more never had a clue. And so I called down to the place in Fort Myers. They don't take insurance, but we found a doctor here in Jackson that does. But anyway, Fort Myers, it was $4,000 to walk in the door. No insurance. They don't do that. And it's a very specialized thing. But I don't think it's surgery basically they do. I think there's some injections that they put in the back of your neck that strengthens the separation point on the vertebra that are collapsing down and causing the problems with your heart. It takes a few injections from what I'm reading. But guys, if you're having problems, you have family members that have problems with their heart, and their doctors keep saying there's nothing wrong, there's something wrong, and it's just as deadly as the actual heart attack itself, because you're shutting it down from the electrical signals from your brain getting trapped and damaged in your neck, which I have a steel plate there and 2 aneurysms in my neck, smaller, but they're there, and a lot of nerve damage. But they never looked at it. I had to find out. Now we're on top of it here. I got an appointment coming up either at the end of this week or next with the cervical angina specialist in Jackson. And I will never forget what they put me through for the last couple of years. And they had no clue. But they were making a lot of money doing it. A lot of money from my, now I'm old enough to get Medicare finally. I waited till I was 67. I think I could have got it 65. I was still working. I just didn't think about it. And so it cost me a little more, but I got it. And so they're going to take that and run with it. Don't forget that. It's good to have it. You need it, but they're going to take advantage of it and steer you somewhere to where they can stay in that money train situation. Anyway, the studies are here, and the heart arrhythmias are real, but do not let a doctor tell you your heart's fine when you know you're hurting, you're having major problems with it, and you should just like maybe slap them upside the head and say, where did you go to school? That's what I wanted to do. Where did y'all go to medical school at? They don't know about a major problem like this. Anyway, guys, that's enough ranting about it, but I did want to put the cervical angina in a video, so this one turned out real good. I was just going to do a video about that, but this will suffice. But look it up. Get a much better understanding of what you may be going through and some possible help. We're watching it, guys. You watch it. It's a heads up. Be safe.